Directional boring, also known as horizontal directional drilling, is a trendless method of installing underground utilities, including electrical cables. While the specific reference to directional boring equipment and cables being installed might not be explicitly listed under the exact phrase in a code book, several sections cover aspects related to it. Firstly, the National Electrical Code, or NEC, provides guidelines for electrical installations. It is important to consult the latest edition of the NEC, as codes are updated periodically. Secondly, Article 300.5 of the NEC, titled Underground Installations, provides requirements for wiring methods and minimum burial depths for cables and raceways. The specific depth depends on the voltage, wiring method, and location. For example, direct buried cables typically require a greater burial depth than cables installed in rigid metal conduit. Thirdly, consider 300.5a, which goes into the minimum cover requirements. Direct buried cable, direct buried conductors, and raceways must be installed according to Table 300.5. This table specifies minimum burial depths depending on the voltage and location of the installation. It's crucial to determine the specific voltage of the cable being installed. Lower voltage cables, such as those operating at 600 volts or less, typically have shallower burial depth requirements compared to medium voltage or high voltage cables. Different locations also have different requirements. Areas subject to vehicular traffic, such as roadways and parking lots, require greater burial depths to protect cables from physical damage. Residential properties and other areas with limited traffic may have less stringent requirements. In addition to the general requirements in Table 300.5, specific types of cables may have their own installation requirements. For example, direct buried cables must be identified for direct burial use and installed in accordance with the manufacturer's instructions. Fourthly, Article 310 addresses conductors for general wiring. Table 310.16 provides allowable ampacities of insulated conductors rated up to and including 2000 volts. These ampacities are based on specific conditions such as the ambient temperature and the number of conductors in a raceway or cable. When installing cables underground, it's important to consider the directing factors for ambient temperature and the number of conductors in a cable or raceway. Higher ambient temperatures can reduce the ampacity of conductors, and multiple conductors in close proximity can generate heat, also requiring ampacity directing. Fifthly, Article 314 of the NEC covers outlet, device, pole, and junction boxes, conduit bodies, fittings, and handhole enclosures. These enclosures are used to provide access to conductors for splicing, terminating, and pulling. When installing cables underground, handhole enclosures may be necessary to provide access to cables for future maintenance or modifications. These enclosures must be sized appropriately for the number and size of conductors, and they must be suitable for the environment in which they are installed. Sixthly, Article 334 of the NEC addresses non-metallic sheath cable, also known as NM cable. NM cable is commonly used for residential wiring, but it's not typically used for underground installations. However, if NM cable is used in an underground installation, it must be installed in a raceway approved for underground use. Seventhly, Article 340 addresses underground feeder and branch circuit cable, or UF cable. UF cable is specifically designed for direct burial in the earth, and is often used for underground wiring to our buildings, landscape lighting, and other outdoor applications. UF cable is moisture resistant and sunlight resistant, making it suitable for direct burial. Eighthly, Article 350 addresses liquid-tight flexible metal conduit, or LFMC. LFMC is a flexible metal conduit that is liquid-tight, meaning it's resistant to water and other fluids. LFMC can be used for underground installations in wet locations, such as areas subject to flooding or areas where condensation is likely to occur. Ninthly, Article 352 addresses rigid polyvinyl chloride conduit, or PVC conduit. PVC conduit is a rigid non-metallic conduit that is resistant to corrosion and chemicals. PVC conduit is commonly used for underground installations, particularly in areas where the soil is corrosive. 10thly, Article 547 addresses agricultural buildings. This article provides specific requirements for electrical wiring in agricultural buildings, which may include underground wiring for irrigation systems, livestock watering equipment, and other agricultural applications. 11thly, other articles in the NEC may also be relevant, depending on the specific application. For example, Article 410 addresses lighting fixtures, and it may be relevant if underground wiring is used to supply power to landscape lighting. 12thly, when installing cables underground, it's important to consider the potential for physical damage. Cables should be protected from sharp objects, rocks, and other hazards that could damage the insulation. This can be accomplished by installing cables in a raceway, such as rigid metal conduit or PVC conduit, or by using a direct burial cable with a heavy-duty jacket. 13thly, it's also important to consider the potential for ground movement. In areas subject to frost heave or earthquakes, cables should be installed with enough slack to accommodate ground movement. This can prevent cables from being stretched or broken due to ground movement. 14thly, before beginning any underground cable installation, it's important to contact the local utility companies to locate any existing underground utilities. This can prevent accidental damage to existing utilities, which could result in service interruptions, property damage, or even personal injury. 15thly, always follow the manufacturer's instructions for installing cables and equipment. The manufacturer's instructions provide specific details on how to install the product correctly and safely. Failure to follow the manufacturer's instructions could void the warranty and could also result in a hazardous installation. 16thly, the Massachusetts Electrical Code is based on the NEC, but it may have additional amendments or requirements specific to Massachusetts. It is important to consult the Massachusetts Electrical Code to ensure compliance with all applicable regulations. 17thly, in addition to the NEC and the Massachusetts Electrical Code, there may be local codes or ordinances that apply to underground cable installations. It is important to check with the local building department or electrical inspector to determine if any local codes or ordinances apply. 18thly, always obtain the necessary permits before beginning any electrical work. Permits are required for most electrical installations, and they help to ensure that the work is performed safely and in accordance with applicable codes. 19thly, consider using a licensed electrician to perform the electrical work. A licensed electrician has the training and experience necessary to perform electrical work safely and correctly. Using a licensed electrician can help to ensure that the installation is code compliant and safe. 20thly, remember that safety is always the top priority when working with electricity. Always de-energize circuits before working on them, and use appropriate personal protective equipment such as gloves and safety glasses. If you are not comfortable working with electricity, hire a licensed electrician to do the work. 21stly, directional boring projects often involve working in public rights-of-way or easements. It's important to obtain the necessary permits and approvals from the local authorities before beginning any work in these areas. These permits may require detailed plans showing the location of the proposed installation, the depth of the cable, and any necessary safety measures. 22ndly, directional boring can affect existing underground utilities, such as water lines, gas lines, and communication cables. Before beginning any boring operations, it's essential to conduct a thorough survey of the area to identify any existing utilities. This can be done using ground-penetrating radar or other locating equipment. 23rdly, if existing utilities are identified in the area, it's important to take steps to protect them from damage during the boring operations. This may involve hand digging around the utilities to expose them, or using special boring techniques to avoid damaging them. 24thly, directional boring equipment must be operated by trained and qualified personnel. The equipment operators must be familiar with the equipment's operating procedures and safety features. They must also be aware of the potential hazards associated with directional boring, such as underground utilities and unstable soil conditions. 25thly, directional boring projects can generate significant noise and dust. It's important to take steps to minimize the impact on nearby residents and businesses. This may involve using noise barriers or dust control measures. 26ly, directional boring projects can also generate waste materials such as soil and drilling fluids. These materials must be disposed of properly in accordance with local regulations. 27thly, consider using trenchless technology to minimize disruption to the surrounding area. Trenchless technology can be used to install underground utilities without the need for open trenches. This can reduce the amount of excavation required, minimize traffic disruptions, and reduce the risk of damage to existing utilities. 28thly, directional boring can be used to install a variety of underground utilities, including electrical cables, communication cables, water lines, gas lines, and sewer lines. The specific type of utility being installed will affect the installation procedures and the materials used. 29thly, directional boring can be used in a variety of soil conditions, including sand, clay, and rock. The specific soil conditions will affect the drilling techniques and the equipment used. 30thly, directional boring can be used to install utilities at a variety of depths. The depth of the installation will depend on the type of utility being installed, the soil conditions, and the presence of any existing utilities. 31stly, directional boring can be used to install utilities over long distances. The length of the installation will depend on the type of utility being installed, the soil conditions, and the presence of any obstacles. 32ndly, directional boring can be used to install utilities under obstacles such as roads, rivers, and buildings. This can eliminate the need for costly and disruptive open-cut construction. 33rdly, always follow the safety guidelines provided by the equipment manufacturer and the project owner. These guidelines are designed to protect workers and the public from injury. 34thly, the NEC is not a design manual. It provides minimum requirements for electrical installations, but it does not provide detailed design guidance. Engineers and designers must use their professional judgment to ensure that electrical installations are safe and reliable. 35thly, the NEC is constantly evolving to keep pace with new technologies and changing conditions. It is important to stay up to date on the latest changes to the NEC to ensure compliance. 36thly, the NEC is a complex document and it can be difficult to understand. If you have any questions about the NEC, consult with a licensed electrician or electrical engineer. 37thly, the installation of directional boring equipment and cables should also consider local environmental regulations, especially those related to excavation and potential impacts on water sources or sensitive ecosystems. 38thly, the selection of appropriate cable types for directional boring installations is crucial. Direct burial rated cables, with suitable shielding and jacketing to withstand mechanical stress and environmental factors, must be used. The cable's voltage rating must also be appropriate for the application. 39thly, when using directional boring for cable installation, ensure that the pulling tension on the cable does not exceed the manufacturer's recommendations. Excessive pulling tension can damage the cable and reduce its lifespan. Use appropriate lubricants and pulling equipment to minimize friction and tension. 40thly, proper backfilling and compaction of the bore path are essential to prevent settling and damage to the installed cable. Use approved backfill materials and compact them in layers to achieve the required density. 41stly, after completing the directional boring installation, perform thorough testing and inspection of the cable to ensure its integrity. This may include insulation resistance testing, continuity testing, and voltage drop testing. Document all test results for future reference. 42ndly, maintain accurate records of the directional boring installation, including the location of the cable, the depth of burial, the type of cable used, and the test results. This information will be valuable for future maintenance and repairs. 43rdly, consider the use of tracer wires alongside the installed cable. Tracer wires allow for easy location of the cable in the future using a cable locator. This can be helpful for maintenance, repairs, or future excavations in the area. 44thly, when planning a directional boring project, consider the potential for unforeseen obstacles such as underground utilities, rocks, or other obstructions. Develop a contingency plan to address these obstacles if they are encountered during the boring process. 45thly, it's important to conduct regular inspections of the directional boring equipment to ensure that it is in good working condition. This includes checking the hydraulic system, the drilling head, and the steering system. 46thly, when operating directional boring equipment, always be aware of the surrounding environment. Watch out for pedestrians, traffic, and other potential hazards. 47thly, directional boring projects should be planned and executed in a manner that minimizes disruption to the surrounding community. This includes coordinating with local residents and businesses, providing advance notice of the work, and minimizing noise and dust. 48thly, directional boring can be a cost-effective and efficient method of installing underground utilities. However, it's important to plan and execute the project carefully to ensure that it is done safely and correctly. 49thly, the directional boring contractor should have adequate insurance coverage to protect against potential liabilities. This includes general liability insurance, workers' compensation insurance, and automobile liability insurance. 50thly, the directional boring contractor should have a good safety record. Check the contractor's safety record with the local regulatory agencies. Finally, remember that this information is intended for general guidance only and should not be substituted for professional engineering advice. Always consult with a qualified engineer or electrician before beginning any directional boring or electrical installation project.